All right, good morning. I'm Charlie Hike from ImageCat. I'm going to be presenting work that we've done for NASA, Earth Observation Derived Critical Infrastructure Risk Index for DRR and DRM. A lot of colleagues involved here: Marina Mendoza, Greg Yetman from CSUN, Shubham Ghosh, Paul Amix, Zhengwei Hu from ImageCat. This can be a little bit different than I think that you're used to with this conference. It's a very macro level analysis. It's derived from satellite data, and we're looking at large impacts. The goal is to be able to anticipate large impacts. It's very different, I think, than you'll be used to, looking at things at a component level or even, a site-specific level. But hopefully that you'll be able to appreciate the utility, and really looking forward to the questions that you might have on the research that we're presenting here. So we start from the basis that disasters have a tipping point, and that economies essentially perform better than expected until they don't, right? So employees can work from home, as we've seen over the last couple of years. Production hours can be recovered by working double shifts. You can use temporary facilities and input substitution. Everybody pitches in as best as they can, until the disruption becomes overwhelming in a way that stops people from having that natural resilience. So infrastructure damage, supply chain interruption, and critical infrastructure damage is lifeline damage is a key impact there, a key factor. The poster child here for what we're looking at would be the floods in Bangkok. This was an event that really took Lloyd's by surprise, which surprised us, given it's you're looking at facilities on the river in Southeast Asia where it rains a lot. But the disruption to just a few hundred facilities there caused massive disruption in the economy for Thailand. But also Japan, China, and other industries that were making SSDs, cars, and so on and so forth. And the next year, if you look at the GDP, it actually shrank by over 10%. So huge impact to the global economy and to Thailand itself. So the typical way to try to analyze this is to do supply chain analysis. But really, there's not enough location data in the world, and it's hard to track down, even if you're working directly with a company. And if you're working with a large company, by the time that you have it established, you got to start over again, because these are so dynamic. To look at this in terms of a supply chain, a network where you can look at individual pieces being severed by damage. And look at the fragility of individual components and how that dovetails into critical infrastructure. There are so many pieces there, and so many dependencies that the uncertainty just becomes essentially overwhelming. So we decided to take a look at it from a very, very different point of view. And it's essentially merging an EO perspective with an economic modeling perspective. So we start from the premise that these areas of massive production, like the industrial sites in Thailand, are visible from space. You can see them. And they're detectable through what's called segmentation algorithms. You can train different data sets with infrared, for example, SAR, synthetic aperture radar, to be able to look at the different texture analysis, textures of the regional area, and basically pull them out. And once you've pulled them out, you can furthermore look at their signatures and be able to characterize the production, the intensity of production at those different locations. So not only can you find where they are, but you can characterize the intensity of production. And that allows you to overlay them with various hazard data sets. So in the lower left here, we have overlaid that with 100-year flood zone provided to us, I believe, by JBA in the UK. And from that, once you've got a flood zone and you've got a location, you can start to disrupt production and make assumptions about the level of damage there and the level of productivity. that might happen given that disruption, and start to change input-output economic models, and basically see how that damage at that location cascades throughout the world. So we've got 3 different examples here that we've been able to put together. I think it sort of demonstrates the breadth of the system. India was our pilot country. So moving, starting here on the left, if you look at a typhoon that actually arrived on the shore there by Mumbai last year, we were able to get basically real-time estimates of surge depth and look at the disruption that was anticipated. And we were able to basically rank these in terms of where we expected the most disruption, given that a level of flooding, and that was by damaging what was there and having that cascade throughout the global economy. So it's just some interesting things. 2 is less impactful than 3. That's actually not a lot of production going on there. And Mumbai, where you have a lot of production, but not a lot of height, ended up being 4. And when we did go back through the actual damage that occurred, this did seem to correlate with the level of disruption into the economy that you had in those various places. In the upper right, we've got the expected 1% annual chance of flooding if it was to happen at each one of those county level maps here, to see where you have the biggest threat for flooding to industrial assets. And then on the lower right, we have a look at the RCP 8.5 sea level rise scenario in the year 2050, and where you would expect a 10% flood 2050 RCP 8.5 sea level rise, where you'd expect the greatest reduction there. So basically, we can do something probabilistically or pseudo-probabilistically, real time, and then looking at climate change, climate condition models into the future. So we've marched this methodology out to lots of interested parties. And the response that we've gotten back has surprised us a little bit. And what people appear to see as the most valuable about this very macro scale, global application, and we do have a global data set in there right now, even though we're just we've got it trained for India, so to speak. There's some problems as you go outside of your trained area, but we can basically tailor it for the whole world. The response that we've gotten back is that it's very useful for ESG, because at this point in time, a lot of people are asking about what the future impacts are going to be, and there's not enough sort of spatial data about different industries, assets throughout the world that allows you to spatially locate those and start to look at the hazards in detail. So we see this as what would be good here would be to have sort of an exposure by sector and country that people could enter into a platform like our enhanced platform that would allow us to produce those sort of results by peril, looking into the forward for different hazards, also partnering with some folks like JBA or Kinetic that might have hazard data outside of our domain, and then be able to produce those maps and results for people for their ESG reporting purposes. But there's a couple challenges with that. One, how do we know how good it is, right? The response that we've had back is, yeah, that's great, but the EO can only do so much. How do we know that it can correctly predict future impacts? And the other is, what does your red, yellow, green mean? And that's a very good point. Really, we come back with dollar numbers. We don't trust those dollar numbers. Those dollar numbers we feel are appropriate for looking at massive impact scales in terms of the sort of order of magnitude of those values. So what we've decided to do is essentially move forward with a scale, nailing down a scale, training it and validating it using hurricanes in the Southeast. We're doing this with partners at Kinetic. They have provided us some data to look at. And we will be able to run that, come up with these dollar values on the county level, compare that with historic things that we can track down pretty well in the United States. So that's a good reason for working here, and be able to tie that to specific values. And then the model that we're using here, as you can see on the left, is the MMI scale. We'll probably just go from 1 to 5. I don't know if we can, we don't have a 1 to 12 scale, but what we're hoping for is not to give anybody specific dollar values or reports on specific assets, but to be able to say, what we would expect the order of magnitude losses to be in those areas in a way that people have a very intuitive understanding of an approaching hazard or a future hazard or changing climate evolving hazard, and how that might impact economic production and critical infrastructure moving forward. So it's a very crude analysis, but it has some spatial specificity that you're not able to get with a supply chain analysis, because you're not able to track all that data down, and it ties that to an economic model which looks at those cascading effects. So very, very different. It shows you where you might have problems. It allows you to go in there and do some more digging. The World Bank can use this to basically prioritize projects moving forward, and so on and so forth. So here's our first cut at this scale. I don't want to spend too much time on this because it's preliminary. We're going to see if this is the target that we can hit using the hurricanes in the Southeast. But just to give you an example, so a low indicator might be something like intermittent interruption of power and communication possible, rapid restoration expected, short-term disruption of power, water, and sewage treatment possible on the order of a few days. Whereas 5 would be cascading impacts into global supply chains. Major disruption to critical infrastructure requires years to recover, impacting nearly every facet of the economy. Severe damage to the entire region's electrical and communications infrastructure, and so on and so forth. So this is preliminary. We would hope to be as quantitative. Even these are qualitative descriptions, but where we say things like widespread small business closure, we want to be able to be as numerical as possible, even if it's within ranges, so that people can take that information. And just like when a hurricane is approaching, you've got an idea of a count 1 to 5. You would have this sort of information as to what the ramifications of hitting in a certain location would be. And then we would be able to use this in the insurance domain, in the ESG domain, in order to look at risk in a way that's very difficult, given that global interests do not have a strong handle on where the facilities are, or what the cascading impacts of disruption is. All right, thanks very much. Looking forward to your questions.